So in this tutorial we'll see how to make bullet holes really quickly, really dynamically into any surface, alright, independent of the surface's topology. So you can use a plane with just one face on it or whatever, and you're going to be able to animate this. It will be super dynamic, and let's just jump right into it. So over here I have some geometry to get us started. I'll go into my GeoNodes setup, and in my Geometry Nodes editor I will click New. First thing I'm going to do is I'm going to spawn in an empty object, and then I'm going to scale it down a little bit and click Ctrl A to apply that. I'll just move this up a little bit, and then I need to bring this empty into our geometry nodes, because the empty is basically going to dictate where a bullet hole is. So get an object info node and pick the empty for that one, and what we want is to set this to, well, first of all, if I plug this into the output, you see that nothing shows up, but if I click as instance, then we see our empty. So we definitely want this to be as instance, and then we also want this to be on relative, so that the position of the empty in actual 3D space is what this gives us. Then I will also get a join geometry node right here for the end, so we can see both of them. And the first thing we want to do is snap this empty to our surface. To do that, we will just get geometry proximity, and the proximity from our surface, which is of course the group input. And then in order to set this up to be where we need, we'll use set position right here. And now if I just plug this in, we should see there is our empty, or rather our duplicate of the empty is now on the surface, the nearest point on the surface to be more precise. Next up, we want to put a cylinder on the same location, so I'll just get a cylinder, and then because it's easier to work with, we're going to convert this cylinder into a instance. So geometry to instance node, just like that. And in order to actually set this guy to the position of our empty, we're going to use the set position command. So once again, set position, and in order to actually get the location of our empty, we need to use transfer attribute. So transfer attribute will be set to a vector, because what we're transferring is the position, which is a vector, and this is our geometry, the source, and then what we need to transfer is index, because we basically have a single point, so when we set it to index, that's just the fastest way to get the position, which is only a single position, so that's why we're using index. And what we want is an instance, because we are working with instances on both sides. I will then set this up to the position of the set position node, instancing right here, and if I move this out, we should see our cylinder. However, it's a bit big now, so I'll just resize by changing the radius a little bit. I'll also change the height to something pretty small, and now we can see that as we move our geometry, our cylinder is basically following through. However, it's not aligned with the faces, and to do that we just need to use a transfer attribute to get the faces of our surface. So to get the faces of our surface, first we need to get the geometry of the surface, which is our group input, and the normals of the surface are again just a vector. So set this up, get your normals just like that. That is the attribute, and we want to be transferring the nearest face. So that means look at the nearest face and get its normal information, and then we use that normal information to just rotate our instances right here. Basically our cylinder is our only instance, and in order to actually plug this rotation, we need to go through an align Euler to vector, which will align the Euler of our cylinder, which is currently with a z pointing up, so we need to use z, to our vector, which is the normal of the nearest face. So once I do this, what we should see if I move my empty around is now that our cylinder is following the surface. For some reason nearest face interpolated doesn't work, so that's why you're seeing this choppiness, but that's why we'll just set it to nearest face for now. Alright, so the first thing we want to do, or rather the next thing, is we want to do some booleaning this cylinder out of our surface. So get a mesh boolean node, and I'll go ahead and delete the join geometry. Instead, I'll just use my surface as the mesh we're cutting from, and our cylinder as the cutter. If I plug this out, we're going to see the following result. For one, we can just remove the n-gon from our cylinder from field type, setting this to none. And to remove the rest of the faces, we're going to use a capture attribute. Now the capture attribute node stores information inside the geometry itself. So if I set it to boolean and set it to faces, inside each face of our cylinder, it will store a value of 1. Alright, and then once the boolean is complete, these faces technically belong to the cylinder, so they will have a value of 1 associated with them, but the faces of our surface will not. What this means is that then I can just pop in a delete geometry node and straight up use this attribute as the selection, but also face for the what we're actually deleting. And now we can see we have deleted that residual geometry, and we can talk about what happens next. Next, we want to extrude some faces because we want to create our own geometry right here. For that, I will just use the extrude geometry or extrude mesh node right here, and I will plug this in just like that. Alright, and so what we get is, first of all, individual is on by default. I don't know why, but there you go. And we want to be extruding just the edge of our circle, but currently, if we set it to edge, it's extruding all of the edges. So we need to get some sort of map or a mask that will be only for these edges that we can plug into our selection for the extrusion. Now, the way we're going to get this is based on the distance to our cylinder. Because if I look at this object from the top down, what I'm going to see is just a square with a hole inside it, and this is the hole we cut out, but the hole also aligns perfectly with the cylinder because it is the geometry of the cylinder that created this hole. So then if I get the distance between the edge, between the points of the edge and also our cylinder, then it will be 0 over here, and it will be 1 for any point over here. So basically the distance from every vertex of this surface to our cylinder, and that will be 0 here and anything other than 0. So then I can set up a cutoff which is like 0.001, very close, and I'll say everything beyond this has a value of 1 and everything after has a value of 0, and that will essentially give us a mask for this edge. To do that, once again, we'll get a geometry proximity. Although remember, we are working with an instance, we turned our cylinder into an instance, so we need to pop that back into geometry by realize instances. So by doing this, realize instances, this is the geometry, using our geometry proximity node. And then if I just pop this through a math node, and I set it to less than 0.001, what I would then need to do is store that information inside my geometry. We now know how to do that. It's the capture attribute node, and this is technically going to be a boolean. So if I pop this in, and then if I set this to edges, because we want to store this information inside the edge of the cutoff, not the vertices, I will pop this into selection, and now you can see we have successfully isolated that. However, by default, the extrude mesh node is pushing along the normals. What we want is for it to push, instead of pushing on the normals, I want it to be pushing inwards. And at the center of this cutoff, remember, we have our empty. So if I know the position of my empty, and also a vertex from this cutting edge, well, these points are basically just relative to the object origin. So this is my object origin. These points are positions in space relative to it, so we can think of them as vectors coming out of the object origin. And when you subtract one vector from that, you get a third vector that is going between them. And this is going to be the vector we'll use when we extrude. Alright, so let's go ahead and get those vectors. First of all, we already have the position of our empty on the surface. Remember, we got that through a transfer attribute at the start, and I'll pop this into a vector math subtract node. So here we go, and then I'll just get the position of my vertices with the position node. This node is of course working out of context, and once I do plug it into the extrude mesh, it will figure out the context is the vertices of my surface. Alright, so then all I need to do is plug that into the offset, and immediately we'll see that first of all it's going in the right direction. We can flip that very easily by changing the direction in which we're subtracting. And the next thing we're going to notice is that it's very strong, so we can lower that. However, we'll see that whenever our points are very close to the center, there's this very weird overlapping happening. This is because the extrude mesh node actually moves the edges, not the points. So instead of moving the points towards the center using the extrude mesh node, I'm going to set the offset here to 0, essentially making all the new faces overlap with the edge. And then I'm going to move them using a set position node, where I will use the same offset. However, everything will disappear then. Oh, but because we need to use top selection, of course. This top selection is actually the new edge we have created basically after we extrude the edges. That's why we need to use top selection into the set position. Alright, so it's a bit strong, I will need to plug this through a vector mat set to scale so that we can change the size of this vector, and we can see that no matter how close they get now, they'll never overlap, which is great. This is basically what we want. However, we don't just want one face, we want multiple faces, and to do that I'll just extrude and set position like this a couple of times, and because I know this will get repetitive, I'll just go ahead and select these and group them with Ctrl G. Alright, so let's go ahead and start doing that. So literally just pick these up, take the extrude into mesh, geometry into here, and we also want to change the direction actually. First off, we want the selection. Remember, this is the last edge we created, so we want to extrude from that edge. So I need to plug this into this selection, and now what we should be seeing is after we also add the offset, because remember, the set position is dictated by this new direction we have created. Now they're basically overlapping, so I will hop out of here and change the scale quite a bit, and now we can see both of the faces. There they are, and I will just hop inside and repeat this a couple of times. I will repeat it 3 more times. The more you go, the more edges you will get inside. So I will do this real quickly, just bridge them over just like that, and then remember to connect the top selection into the next extrusion, because that is going to be the extrusion mask basically. And after all is said and done, we will end up with this result. Alright, so as we can see, if we keep increasing the scale, we are getting closer to the center. However, our points are getting quite disproportionately moved towards the center. So why is this happening? Well, if I go back to my top-down diagram, what I have essentially now is a bunch of concentric circles, and what this node gives me, right, is the vector from the empty to every point. So a vector going like this, right, from a point here. But if a point is here, this vector will be like this. So suddenly this vector has a different size, and basically I want to use the same size for all of them. And to do that, I will simply use a capture attribute over here once again, and what I'm going to capture is a vector, and what I'm going to capture more specifically is this very vector right here. However, I will scale it after I have plugged it in. So basically this is the situation we're going for. This goes into here, vector into here, and now if I just reduce the scale, we'll see that now they're all the same distance away basically. However, we'll see this weird jaggedness. That's because we stored the information inside the edge. We need this information inside the point. Alright, other than that, I'm noticing that a lot of the geometry is very close together, like over here and especially over here. These are way too close together. That's not good, and we want to fix that. In order to fix that, we'll just merge by distance. So get the merge by distance node and plug that after we have gotten our mask, because then we can use this mask of the edge to only merge points that are at the edge. And you can see how those are gone. However, this is way too high of a distance. I'd probably reduce this a little bit and then a little bit more again. We're basically looking for a pretty even distribution of points. So I'll keep it like this for now. And we can talk about how to proceed, because we're basically done with generating our geometry. However, one more thing, you notice that it's pretty flat now, and if I remove my viewport overlays with this button, or I just have a shortcut for it, you can see it's pretty flat. That's because we basically extruded in a straight line. So after we are done with all of these extrusions, we want to snap everything back to the original surface, and that's just another set position. But we also want to plug into here, if I press N and get a geometry, so that you can get a socket for that outside of this group. We want to plug in here the original geometry, which is our group input. And what I can do this is call it original, which is just the unboolean mesh. And then I can just do another geometry proximity, which will again give me the closest point to my geometry right here from this position. That's what I'm going to snap to, but also I'm going to mask out only the points that are inside only my bullet hole geometry, which is of course what this mask provides. And by the way, after we extrude, remember this stored the information of the boolean only at the edge, but when we extruded, that information got propagated. So now later on this functions as a mask for every point of our whole geometry. So all of these points now have a value of 1 coming out of this socket. And that is why it is important. We will be using this as a mask for a lot of our nodes in the future. So I'm just going to get it like that. And let's talk a little bit about actually pushing this geometry out. So to do that, I will just use a set position node right here. And I will again use this as the mask. Remember, I just said that this is actually the geometry of the hole. And I want to push on a vector that is dependent on two other vectors. Basically, if I go into this view, I want to push on the normal, which is easy. I already have a normal node. But I also want to push on the tangent. And if you pay attention, the tangent is actually just the vector we got right here, the same vector we were extruding by. So I can straight up use that, and more specifically I will use the tangent we got from this capture attribute. However, I do want to plug this into a normalize, because by default, if I cut out a very rough surface like an octagon, for example, if my cylinder had only 8 points, and if I do get this distance, remember, that comes out of this vector, it will be fine, right? It will be the same for all of the points because the cylinder is at the center, if this is my empty. However, because we're booleaning, we might end up with a point right here, because if there's a face here and then we boolean, it will create a point here, and then the distance here will be actually different. Not by a lot, but it still will be different. So to account for that, we're just going to normalize these vectors. And when you normalize a vector, you're basically setting the size of every vector to be equal to 1. Right? If I have just a random vector here just to illustrate, and then I normalize them, they certainly both become with a length of 1, but they keep their direction. Alright, so that's why I'm normalizing. Next up, I'm also going to want to flip this vector because currently it's pointing inwards. Remember, we used it to extrude inwards. So that's just another scale node set to -1. So now we have normalized our vectors, we have flipped them, and we can finally use them as the tangent vector. Now to mix two vectors into a new vector that is sort of pointing in this direction, I'm just going to use the mix RGB node because it already mixes 3 numbers, so it's basically exactly what we need. However, I'm also going to need another vector mat, or rather, let's just plug this in and see what happens. It explodes, of course. So we need a control for this. That would be another vector mat in between these, set to scale, and now we can change the size of these vectors, essentially the strength of our push, but it's also the same everywhere. For it not to be the same everywhere, we need a map. Basically a map that's at 0 at the edge and 1 at the center. So the way we're going to get this map is we already have this vector, which remember is just a vector pointing inside, and if you get the length of this vector, sometimes called the magnitude, that is actually the distance from the edge. So I'm just going to copy this node and set this to length, which will be the distance, like I said, and I know for a fact that this distance is 0 at the center, right? For points that are already at the location of my empty. That makes sense. Maybe I'll just draw this one more time just so I can illustrate the point. So this is my empty, and these are the concentric circles we have created, essentially our edge loops. And something here will have a very small value, something here will be like well, let's talk about what this value actually here will be. This will be just the radius of our cylinder, right? The final since we booleaned using the cylinder, so that would be the radius of my cylinder, and over here it would be 0. And we want to remap this such that it is 1 over here at the very center, 0 here, and 0 for all points throughout. So to do that, that is just a map range node. There we go. And I just take the length, I plug this into map range, and the from maximum is this radius. So it needs to be the same as my radius of the cylinder. So I'll pick that up real quickly, and I'll toss this into the from maximum, remove the M, and flip it, because as I said, we want this to be a 0 to 1 map. Then if I just scale all of these up by this same amount, we can see that now we have that gradient we were looking for. However, we did lose the control for the scale, but we do want it to be individual for each of these two vectors, the normal and the tangent. And to do that, I'll just add another scale for each of them. Now I have a control for the push on the normal, a control for the push on the tangent, and yeah, that's pretty much what we were going for. If I just scale this down a little bit, However, we're going to be noticed that we're pushing very linearly. It's just the same. It's constantly increasing with the same amount. So to fix that, I'll just plug in this 1 to 0 transformation through a float curve. If I can find that. So plug that right into here, and that will let me change this transformation as I wish. If I do like that, there we go. Suddenly we're basically almost at the effect we want. Of course, this is already dynamic, and you can play around with this. However, this final edge here we can adjust if we change the push on the tangent. It's gonna get pretty stretched. To fix that, you can add one more point over here and lower the maximum because this is why this is happening. So you can definitely play around with this float curve to get something more specific. But yep, this is pretty much our bullet hole, good to go. Let's talk about how to make it a bit better, because I want some jaggedness on the edge. I'll probably extrude this back out a little bit, because what we're going to do next is another set position to just get a little jagged on the edges. So basically I want to plug into this selection a map that is only for these edges of the bullet hole. And I already have a selection for all the vertices of the bullet hole. And I also need another one that is just for these edges. So I can get that with a edge neighbor, the edge neighbors, which gives me the face count for each edge. Now these edges at the very rim only have one face neighbor, while these ones, all the other ones have two. So I can just plug this in through a math node and just say, okay, if the faces are less than 2, right, then that is what you select. However, this will also select these at the edge over here. So basically we want to combine these two booleans using a boolean math. So I'll get my boolean math and I'll set it to n. So whenever this and this is true, only these are the faces you'll be moving. And I can test this out if I just move it on Z. Yep, now we only have a selection for our corner, for the edge of the bullet hole. And to add it a little bit of randomness, well, we need to actually move these points on the new vector we created right here. So that is the vector that's coming out of the mix. And in order to get information out of it, because I already moved the points, I really cannot recreate this setup here again. So I'm just going to capture this as an attribute right here. This is a vector, just like that. And then this attribute is going to be the direction of my noise at the edges. So to actually use that, I will plug this in through a vector math so that we can scale it. And then I will plug this into the offset. And for the scale, I'm going to actually just use a random number, because that actually random value. Set maximum to 0, and then I'll just move the minimum back a little bit. And what we're getting is these pretty jagged edges, which is, if you look at the bullet hole, this is pretty close to how they look. Yep. And one more thing, if you want even more geometry at the edges, so you can get even more jagged edges, well, what you would need to do is go to your cylinder and increase the vertices. So something like 64, I will give me even more edges there, just like that. So yep, this is how you get even more detail there. However, I also want another set of noise, which will be like bigger noise for the overall shape. So after this position, and for this one, I will just use a noise texture. However, the noise texture gives a color, and colors are just 0 to 1 RGB, but what I want is a direction in space. In order to account for that, I will just subtract from the colors 0.5, which will center them on the world. And next up, again, we plug this in through a scale, and again I will just set up the offset. However, I don't have a selection, so once again I will take my selection for the vertices of the bullet hole, just like that. Shift right click to cut it out, and yeah, it's there, but it's working again on every point equally, every point of the bullet hole. So we'll basically need another distance map. However, again, I cannot get this anymore over here. I'll need to capture it as an attribute right here. It will be a single float because it is the distance to the center, to the empty. And I got this out of this float curve, so I'll plug this into here. And then I'll be able to access this into my noise right here. However, I just lost control of the scale, so I'll need another scale. And now you can see how we're affecting the edges the closer they get to the end. Yep, there we go. For this, I would probably no detail, no roughness, and just play around with this boost right here. Of course, this will depend on the scale of your scene, so keep that in mind. Maybe I'll lower it a little bit so you can get even bigger noise. And yeah, there it is. Now it has a lot more deformation, like on a bigger scale. If in the modifiers tab afterwards we add a solidify, and I'll set this up to something like 2, so that's pretty thick, like a thick metal. And then I want to bevel these edges. To do that, I'll simply add a bevel modifier, and I only want to bevel these edges, so I can actually capture them as a vertex group inside the solidify modifier output vertex group rim. However, I do need to give my object a vertex group, so I'll just give a default one called group, and then I can plug that into the rim, and I will have access to it inside my bevel modifier. If I set limit method to vertex group, and then I can pick this group, it will only bevel the edges of the metal, basically. And usually what you want to use for the solidify modifier is even thickness and also normals, high quality normals. So those just help the look a little bit, and also the bevel 2 segments looks much better than 1 segment. So there we go. Now we are getting there. What else? Let's talk about materials a little bit. So I have given this thing a material. If I click this, you're going to see it. It is just, if I go into my shading, a basic setup with a bunch of textures, just a PBR setup, nothing complicated. And the first thing you'll notice is that over here this thing is stretching because it doesn't have any information there. In fact, that is a problem that by default we can solve if this decides to drop down. So this vector input right here is very interesting. It basically tells us, or rather tells the texture, what space to use when mapping them onto our geometry. And currently by default it's using generated. If I get the texture coordinates, the generated coordinates, which are based off of the geometry, you can think of them like that. But what I'm going to do is I'm going to base them off of the object coordinates, which means that it will just use the object origin, basically. The problem is, yeah, see, this works, but the problem is if this geometry moves in any way now, if I go into my geonodes, and I do want to pin this so it doesn't go away, and move, for example, the push over here, you see how the texture is also moving, because it is using the position of the geometry in space. But I don't want that. I basically want to use a custom position. More specifically, if I go over back here right after we extruded things, right here, this is our, maybe we can rename it extrusions, whatever. We extruded, basically what we got out of here, if I plug that to the end, is this flat face. And this is kind of the situation, the UVs I want to be using when even after I deform things. And what I can do is I can just capture the position of all the geometry at this point. So another capture attribute, and what I'm going to capture is the vector, which is just the position. So the position vector of all of these points right after we have extruded, and then I can plug that out into my group right here. Of course, I don't want that to be slinking all over the place, so I'll make it a bit nicer. And then if I go into the output attributes of my geometry nodes modifier, I can just call this something like new UVs. Yep, and make sure you get this name correctly when you transfer it over into your shading network. To actually get the information, we'll just use the attribute node and plug that name in here, new UVs. So now if I just use this instead of the object coordinates, it is going to use the position of the vertices right after we extruded back there in the geometry nodes tree. So essentially it looks pretty similar. However, now if I hop into the geometry nodes and change again the scale, for example, we can see that the texture is staying put in space even after we're deforming. So that's really important. However, you see at the edges it is getting very distorted, but we're going to mask that out a little bit, which is of course because over here where we captured them, remember this extrusion just gives a bunch of points that are one second, that are like this, right? So that is what it was using, although I would need to use this one right after the capture. Yeah, so this is what it's getting, and over here they're really close together, these points, so they're getting a bit stretched afterwards. Yep, and to fix that, I actually need to outsource one more bit of information, which is the distance from the edge of these points. And remember, I got that out of my float curve inside this capture attribute, and all I want to do is output that in the end as well. And if I plug that out just like this, and in here I will call it dist for distance. I hop into the shading editor, and with another attribute node I can bring that in just dist. And if I plug that into the surface just so we can see what's happening, you see that it is indeed the distance from the edge. And what I can do then is use this distance map. I'll just temporarily disable this to use something like mix RGB or mix shader. And I can just take this shader and another principled BSDF right here, mix them all together while using the attribute right here, the factor, as the factor right here as well. Plug that in, and if I go into my shading and give it a second to compile, I should see, however this might need to be flipped. There it is. So now we get a different material right at the edge. So that's one way to hide that stretchiness. For example, if you give it a bit of metallic, now it looks like the metal has been like worn down, like stretched, I suppose. What else can you do here? I guess you can also use this map to give it a little bit of glow, like the moment of impact, or like it was punctured by something very hot. To do that, simply plug in the factor into the transmission, or rather the emission strength, by also going through a matte node so that we can boost that up, because currently it's very weak. Remember, we're using a 0 to 1 map. So multiply, set up a color, something bright, something like yellowish, and then just pump up this, and also in your render properties enable bloom for Eevee. You're gonna get this. You can taper that off more towards the end if I just plug in a power here, because remember, a power function just turns a linear transformation into a more curved one, just softens that up really easily. You can also do it with a float curve, but you know, it's up to you at that point. Exponent is way too high here. Maybe even 4 to really get those edges popping off. There we go. And it's all dynamic, of course. There we go. And this is great. However, how do we animate this? Because it's all good to be static. And this would also work on any geometry right now. If you get a plane with a single face on it, it will still work because we're creating our own geometry here. The caveat, of course, is that we are using object coordinates, which means that over here, if I decide to extrude this edge, it's gonna look bad because this is Z. It's not gonna work, and just keep that in mind because object coordinates basically as if we're looking from the object, like from above. And yeah, that's the one caveat of this technique. It won't really work with UVs if you want a smooth transition at the edge here. Let's talk a little bit about animating this. In order for us to animate this, we need to output some attributes into our group input so we can control them from the modifier stack. Starting from the beginning, what we would need to output is definitely a control for the number of vertices. That's important. Definitely a control for the object, so I'll plug that out as well. Most of these things we don't have to touch. However, if I get another group input, definitely a control for the merge distance. This is important. A control for both of the position on the normal, and or rather the push on the normal and the push on the tangent. I will rename this. So this is push normal right, yes, and this is push tangent, tangent-y, sure, whatever. Distance isn't very self-explanatory, so merge dist, that makes more sense. Vertices makes more sense as resolution. What else would we need to output? The jaggedness of the edges from our random value, that's an important one. I guess also for the noise, what I like to do is I like to use a vector. I'll explain why in a second, because a vector is 3 values compiled into one, right? And for the noise, we actually want to control 3 things. And by keeping it as a vector, it also looks a bit better on this node. It doesn't get too long. And in order to unpack that, we'll just go separate XYZ, get this vector, and then I want, I'll set this to 4D noise so we can actually change the W as well. I want X to control the W, Y to control the scale. So I'll plug that out like this, but I also need to give it a default value, both here and in my modifier. And also the scale, same thing, here modifier, and the scale is going to be my Z, just like this. Shift cut, a little bit better. And now I have a control for the scale, for the noise. I'll rename this to noise. I'll rename minimum to edge jag, because it takes care of the jagged edges. And at this point we're almost good to go. If I hop into main, and then I will also maybe delete some of these doodles, I will pull out a timeline. Oops, what did I do? I'll pull out a timeline, and I'll start keying stuff. So what we need to animate are three properties. If I go to the start and into my modifiers tab, we can see all of this stuff. What I really want to set is push normal to 0, and then I'll press I to key that. Push tangent to 0, again I to key that, and also the scale of the noise to 0, and I to key that. And now we can see this pinhole. In order to hide this, what you can do is you can disable the modifier entirely before the bullet hits or whatever. So that's one idea. You can also make it a bit smaller inside your geometry nodes if you just change the scale here, which we used for the extrusion a bit more accurately. So something like 5 would get us even closer. So keep that in mind. And then what we want to do is move like 30 frames forward, and basically move this out until it's something we're happy. Again, press I to key those, give it a little bit of noise. There we go. I'm just playing around with it. I'm keying these, and then in order for this really to pop off in the middle, what I like to do is really push up the normal push, and what that's going to give us is this opening effect, just like that. And you can see that it's a bit slow now. I honestly dragged it out way too much, so maybe like 20 frames would look a bit better. There we go. So that's popping off. It should work with the materials just fine. However, bullets really push from below. What I mean by that is maybe this isn't quite how you want them to work. We can give a little bit of push the following way. So currently we have this float curve, right? But if I have another float curve, and I just set this one to be, well, if I mix these, right? So another mix RGB node to combine these float curves, and then the result of this is what I use to drive the scale wherever I connected the float curve. Then what I'd be able to do is, if I change this completely to the second one, which is this float curve, is I'll be able to set up like a situation where this is protruding out, and if I scroll forward you see what we get then. And I can have a control for this factor. So let me grab my group input. I'll just separate this, add another, or just plug that out like that and call it push. You can also animate that. So over here, for example, I just go push 1, move it forward until I'm happy with it, and then bam, over here I'll just reduce it, which will sort of pop it off. There it is. That's sort of what I'm going for. And you can probably do a better job with a few less keys. I probably overdid it here. If I change the frame rate to, rather the maximum frame to 20, I can just let this play and start moving this around, because it's totally on the spot, it's totally dynamic. So one other important note is how to duplicate this. So if I want a single surface to have multiple bullets, well, you just shift D on Y and then you get a second one. And over here, if I just shift D the modifier itself and then change the empty that it is using, you'll see we get a second one that is not animated, but you can copy these keys over to the next one. We're going to notice, however, that over here we're getting a bit of stretching, and also if I enable and re-enable the second geometry nodes, we're losing that distance mapping. That is because it is remapping. See, I'm using the same attributes here, and in order to fix that, we basically need to mix the attributes of this node and the next node in a special way inside our geometry nodes editor. Basically, I need to pick up the last attributes over here, and to do that inside my inputs I'll add one more that is called vector. and I'll actually call this prev UVs, so we know that these are the previous UVs, and I will get a group input into here, group input, and to get these previous UVs into here inside my second geometry node, there they are. I'll just click this button and then I'll be able to select an attribute. So it's called new UVs, which came out of here, and now it is prev UVs. And then these UVs, I will use a mix RGB to combine them. So this would be the first one, and then this would be my second UVs. And then what I will do, and I'll explain this in a minute, I'll pump these UVs through a greater than node, and then that will be my mixing factor, with this value being something pretty low, like 0.1 for example. And now you can see how if I turn on and off the second geometry nodes, we're no longer getting that issue where it's stretching the area here. So basically what happened here is, if a previous vector, because currently what I've done is I've introduced more points that didn't exist inside these previous UVs, and so I can say whenever it tries to mix them up, it will give just 0, 0, 0 for this vector. And then I can say if the value is greater than 1 or greater than 0 or something close to 0, this will pump out a value of 1, which will give us the second color, which is the original UVs. But if it is 0, in other words, if those UVs don't exist, if that point doesn't exist, which is the case for all the points of the new bullet, it will give 0 over here, because it will give 0, 0, 0 for these vectors as well. And then it will just select these new UVs for that instead. And that is how we're going to mix these up, basically. I hope this makes sense. As for the distance, because the distance also mixed up, we can fix the distance much easier. It's just another input over here, which is a float, and we're just going to pump in the, again, previous UVs. Just pump in the distance, although I will rename this to previous distance, so you don't get confused. So this is the setup, and then I have access to it, and the distance function is the one we got right here. I do believe that is our distance, or rather, yeah, this is the one. I want to just combine it with a simple add. So a simple add node, or you could do multiply as well. Also, I think, multiply wouldn't work. Yeah, you would need to use add here. So add these with the previous UVs, and then that is what I'm going to be outputting in the end. So that would be over here, I believe. And you can see how that fixed that up. So now if I enable and disable the second modifier, basically very little changes, almost nothing, which is what we wanted. And from here on out, it's much easier to add other ones now that we have that system in place. Just shift D this, change the empty, and there you go, another bullet. And you can go ham over here, add as many as you want from here on out. That's basically what I wanted to point out. And I'll probably make this available on either Patreon or Gumroad, whichever one I end up choosing. And yeah, thanks for watching.